Let's continue with expandable mold and expandable pattern type of casting processes. As the name implies, once you perform these casting processes, you have nothing left. You need to use new mold and new patterns. The first type is called as evaporative type of pattern casting. And in this process, we make use of mostly polystyrene type of pattern made of polystyrene. And that's why it is sometimes called as foam, loss foam process. And since it's an expandable pattern process, so it should be actually lost at the end of this process. And this is highly useful, especially for ferrous and non-ferrous metals, which have very high melting point temperatures, and they are mostly used in different industries, especially in actually automotive industry. And we have a nice schematic showing this process. You see, first we prepare the pattern made of actually polystyrene, and then what we do, if you are going to manufacture many of them at the same time, you may we should place them on a kind of a cluster, and then we apply some coating on them so that the shape is not modified, and further we put them into a kind of a flask and kind of a container and fill the remaining part of the container with sand, and later do the casting. So we simply pour our molten metal onto this polystyrene type of pattern, and once you pour this molten metal, since its temperature is very high, the melting point temperature and evaporation temperature of this polystyrene is not that high. So once you pour it, the material here inside the pattern actually evaporates, and the cavities are simply filled with molten metal. And once you wait enough time, then the molten metal obviously will be solidified, and later you can simply shake it out and remove your casted products. So what are the advantages of this process? First of all, not a complicated process. The only thing is that you need to prepare your actually patterns made of polystyrene. That might be the difficult part, but you may use simple CNC systems, or if the part is not complicated, even you may prepare the pattern yourself. And another thing, we are using inexpensive flux, so they're not complicated, they are simple, and the material itself is inexpensive. You can easily obtain it and shape it, and later, once the process is over, you don't need to do any extra finishing operations or higher, let's say, difficult cleaning operations. Things are much simpler. So for ferrous and non-ferrous metals, people prefer to use loose form type of casting process. And you may have some actually specific type of machines or lines, so that this casting process system may be automated, and you can use them for long production runs instead of a small number of production. Then we have the second type, it's called as investment casting. And in this process, actually, we mostly use wax type of material instead of foam. This time we are using wax, but there is a little difference. What is that? We prepare again a similar pattern tree, but for the preparation of the pattern, you may use such injection molding, or these days we prefer to use 3D printing, especially a stereolithography type of 3D printing, to obtain these wax patterns. And then what we do, we place them on kind of a tree, and again do some coating on the outer surface of these actually patterns, and then we prepare our mold with the help of some extra coating, and then later we put this actually pattern into a kind of an oven, and the temperature of the oven is increased. We apply heat on this mold, and with the help of this heat, the wax actually inside this mold is simply evaporated, and we only have cavities left, so we don't have any wax inside this mold. So that is actually ready to be used in the casting process. Later, we simply pour our molten metal into these cavities and obtain the 3D products, obtain these casted products. So this is the main difference. We actually heat this mold, in an oven so that this wax material is evaporated. But in the loose form type of casting process, we don't have such a stage. We simply pour our molten metal into the prepared, let's say, mold. And these are things that I discussed. We have another example of investment casting. It's called ceramic shell investment casting. The thing is that its quality is a bit better. So for that purpose, in order to increase quality, we have some extra coatings so that your overall quality is improved. Now we'll discuss another type of casting, another group of casting processes. These are called as permanent mold casting processes. If you remember at the beginning of this chapter, I said that some of the molds are expandable, which means that you're not going to use them again. But on the other hand, you may also use some permanent molds. And if that is the case, that means you can use the same mold for maybe 1,000 times for your casting operation. But the thing is that obviously you can produce the same product. With a single type of mold, you can only produce a single product, a single type of product. And the first one is actually, this is by the way, the general name, the group of casting processes. And the first one has a similar name with the group. It's called as permanent mold casting. Now we will discuss some fundamentals regarding this casting process and then go on with some other permanent mold casting processes. And actually, in this permanent mold casting process, in order to increase the life of our mold, we usually make use of some materials having high resistance corrosion, high thermal fatigue, so that they can be used again and again. And such materials like cast iron, steel are used in the formation of these molds. Another thing is that if you remember the sand casting process, we have a different pattern, and then the sprue and other gating systems are placed while you are actually putting them into the sand. But this time, you should be actually machining these cavities and the gating system at the same time on using actually CNC systems for most of the time, so that their dimensions are highly accurate and the surface qualities are better. And on the other hand, again, as in the case of sand casting, for some hollow shapes or complicated shapes, we may need to use cores. And for that purpose, again, we should prepare cores separately, and they may be made of, again, sand or even sometimes steel may be used. But the advantage of sand is that once you have the casted product, by simply shaking and applying little force, you can collapse the sand core and get your part. But if your core is actually made of steel, then that means it's not actually easy to remove from your, let's say, curved shapes. So you should be aware of this problem and try to design your mold and core accordingly. And since our aim is to use this mold for many times, for 1,000 times, so what we need to do, we need to have some kind of lubrication. And with the help of this lubrication, we increase the life of the molds, and we increase the material flow, and with the help of them, you have much better surfaces. And these are usually made of sodium silicate, clay, and some other type of materials are used for that purpose. And we usually spray it maybe after 5, let's say, casting operations, or even maybe in some critical applications, you may need to do it after each actually casting operation. And the fundamentals are similar actually. Once you prepare the mold, you actually heat the mold a little bit so that we have better metal flow and the thermal damages decrease. And then later the rest is somehow similar to sand casting. We simply pour our molten metal, and through the sprue and other things, other gates and runners, our molten metal moves into the cavities. And then once you actually put all the metal inside, then you will wait for some time so that the casting is solidified. And then later you'll open the mold and have your product. And in order to have in this process a uniform cooling, we may use some special cooling channels, and then inside these channels, water may be pumped actually continuously so that we will have a uniform cooling throughout the mold. And we make use of this process for mostly aluminum, magnesium, and other type of alloys having a bit lower melting points. Even you can use steels, but it's not preferred for steels and some other metals having higher melting points. We prefer to use sand casting operations. And compared to sand casting, obviously, this one has better surface finish since the mold is prepared by using mostly CNC machining. We have much smoother surfaces. With the help of them, the surface quality is higher and the dimension tolerances are better. On the other hand, if you want to increase the quality, then you need to pay actually a lot. The machining of these dies are highly expensive, and that's why it's not for actually economical for small numbers of production. If the part is going to produce for 1,000 times, for 10,000 times, then it's better you go with such permanent mold casting operations. And on the other hand, this is not suitable for complicated shapes. You need to go with other casting operations if you have some intricate shapes, intricate features on your design. And then we have another type of permanent mold casting process called as vacuum casting. As the name implies, this time instead of gravity or pressure, what we do actually vacuuming. This is a nice schematic of the process. We have an induction furnace, you see, and inside this kind of a pool, we have molten metal, and this is our mold prepared. And now, once you actually dip this mold into the molten metal, then we will use vacuuming. And since this air is actually removed, all these cavities will be filled with molten metal here, and that is actually mostly used for shapes, complicated shapes having very thin walls. And another issue is that advantage is that the properties of the walls of the shape will be highly uniform. Then we have another permanent mold casting process called as slash casting. This was a thing that we discussed in the previous chapter. If you remember the thing that we had 4 stages. It doesn't have to be just 4, but from time to time, you pour some molten metal into your cavity and you check the thickness of the walls. Once actually you are satisfied with the thickness of the walls, then you can simply pour the molten metal out of your part and have your product ready. And this is highly suitable for small numbers of production, not for mass production. And with the help of this process, we can easily produce some ornaments, some simple shapes, but not complicated ones or not the ones for mass production. Then we have pressure casting. As the name implies, we make use of some extra pressure in addition to the gravity, and we actually hold this pressure until all the material is solidified inside the cavity, and with the help of it, the surface quality, dimensional accuracies are much better with this extra pressure. Then we have die casting. This is another permanent mold type of casting process. With this one, actually, again, we apply some pressure, but the thing is that we are using some specialized dies in this process, and this is mostly useful for large production runs. And we will see that there are 2 types: hot chamber process and cold chamber process. This is a schematic of the hot chamber process. You see, we have kind of a furnace here. It is obviously heated to very high temperatures, and we have a molten metal here. It's inside this pool, and then with the help of this hydraulic cylinder, it's called this hydraulic shot cylinder. With a single shot, we actually supply some molten metal through this gooseneck and the nozzle into the die cavity. And then, as in the case of other permanent mold casting processes, we wait until the material is solidified and then remove our product with the help of this ejector pins, and then we may start another casting process. But the thing is that we mostly use it for low melting point alloys. We cannot use it for the materials having higher melting points, since if that is the case, then the temperature of this furnace will be increased to very high levels, and it's quite difficult to maintain these parts at these high temperatures. So that's why it's only used for materials or alloys having low melting point temperatures. But on the other hand, for the cold chamber process, this is an example of it. We may make use of we may cast alloys having higher melting points. And since we don't need to heat the chamber, we don't need to heat all these equipment, what we do, we simply bring our molten metal into that shot sleeve, we pour it, and then with the help of this piston again, we pump this material into the cavities. And this is much, as I said, much frequently preferred for materials having higher melting points. So this is the advantage. Actually, the chamber is not heated, so you are not actually wasting too much energy. But in the previous type hot chamber process, we are heating all this furnace, so the consumption of energy is a bit higher, and that's why we only prefer it for low melting point alloys. And another issue regarding this die casting process is that you may embed some actually mechanical components inside, like the pins, shaft, some maybe fasteners like screws can be embedded into the casting, and this is called as insert molding. And in order to increase actually the interfacial strength between them, you may do some extra knurling operation on the surfaces so that material will be going into all these cavities, and there is a bit better actually connection between the insert and the casted product. And for die castings, we have different options. We may have a single die cavity like in this one here, or we may have multiple cavities of the same product, or we may have different products in the same die, or this is much more flexible. You may have unit dies and then you may join them together to produce different products at the same time. So if you are going to produce, let's say, less number of products, then that might be the best choice. But if you are going to produce high numbers of the same product, then it's better you go with multiple cavity type of dies. And for most of the time, the dies are usually the weight of the dies are very high, and we have a ratio of 1,000 between the weight of the die and the weight of the product. This is a very huge number. So this is very small, and the die itself is a very larger one, and the weight is huge compared to the weight of the casted product. Then we have some other permanent mold type of operations, casting operations. These are under the category of centrifugal casting. And obviously, in this process, we are making use of inertia. And this is caused obviously by rotation. And there are three types: true centrifugal casting, semi-centrifugal, and centrifuging. Let's have a look at the first one, true centrifugal casting. This is the process actually. This is the side view, right view. And you see we have some rollers here. This is dry roll, and this is for supporting the mold. And what we do, we actually pour our molten metal into this mold, and since the mold is rotating, so due to the inertia, we will have actually material at the boundaries of this mold, but the interior will be empty, and this is called as simply centrifugal casting process. Then we have semi-centrifugal casting. This is a schematic of semi-centrifugal casting. You'll see we usually produce some, let's say, axisymmetric parts with the help of this process, and this is somewhat similar to the other casting processes. We have a kind of an gate and pouring basin, so we pour our molten metal at the middle of this equipment, and then again, due to the centrifugal forces, materials are actually flowed into these cavities, and we continue this process until all these regions, all these cavities are filled with material. And the third one is called as centrifuging. This is a bit different than the previous ones. Again, we have rotational motion, but the thing is that this time we have cavities, part cavities on the outer region of the actually rotating part. We pour again our molten metal into that center, into the middle of this equipment, and then due to the centrifugal forces, they are actually transferred to the cavities on the boundaries of the equipment. And lastly, we have another type of permanent mold casting process. These are called as skews casting and semi-solid metal forming. In the skews casting, we make use of actually the fundamentals of casting and forging processes. You see, this is actually kind of a punch and also a kind of a die. So we pour our molten metal into this cavity and then do a kind of a forging operation so that the material is going to take the shape of the die, and also its dimensional accuracy is improved. So you don't need to do further forging operation. If you remember the advantage of forging, with forging, we will have specialized actually grain flow around the boundary, and that will increase the strength and the hardness of the product compared to just the casted products. And then we have actually a brief topic on composite mold casting processes. That's nothing actually new. If you want to actually improve the quality of your molds with different materials by the combination of different materials, then it's called as composite mold casting. And with the help of them, as you see, the strength, accuracy, and surface finish of the resulting product is improved. And once you have these nice advantages, then your overall cost will be decreased, and obviously the processing time again will be decreased since you don't need to do extra operations after the casting process. And that is all for casting. Make sure that you look at the questions at the end of this chapter.